let's do some examples, huh? Have to get through that derivation, looking at all that dang algebra. Why don't we see what's up so you can do your worksheet, see your homework. Put it in the past. So let's go find the angle between the following vectors, and let's just round to one decimal place. Let's keep it simple. There will be some rounding involved. Now, of course, we're going to need our formula. So let's pop that thing in. Let's put it somewhere we can see it. Say theta is equal to cosine inverse v dotted with w over the magnitude of v times the magnitude of w. So what we're going to need to get is v dotted with w, the magnitude of v, and the magnitude of w. That's how we solve these problems. Then we put all that shit together, we plug it on in, and we get our answer. Everybody's stoked. So let's go get v dotted with w. And that's just take your two components and multiply them together. 5 times 4 plus, and now we'll multiply our j components. 12, negative 3. And what do we get? What's that? 20 plus negative 36? What's that? Negative 16? Negative 36? Yeah, 3 12-packs. I got that shit down. That's 36. 20? Yeah, okay, we're good. All right, now let's go find the magnitude of v. Maybe you recognize this thing. Maybe I should draw something else. You know what I mean? We're doing this. Let's take a look. What's going on? Let's get that visual going. We got what? Vector v, 5, 12. So we got something going kind of big, right? 5. So it's going all the way up to 12. And then we got our vector w, and it's going towards the negative y is positive. Oh, so this one's going to come over like this. Well, it doesn't quite make it all the way over. There's vector w. Oh man, it looks like almost like it's a 90, but you know my shit's not to scale. Cool. So when we're actually going to find magnitudes of these vectors, it's just the hypotenuse of a right triangle, isn't it? So let's go back there. Just want to make sure we see what we're doing and why we're getting angles, and okay, moving on. Let's go get that magnitude, which means square up your components. So 5 squared plus 12 squared. Right, a 5, 12, 13 triangle. It's equal to the square root of 169, which is equal to 13. Keep using those same ones just for fun, you know? Now the magnitude of w. If you're not seeing this yet, I don't know what else to do with y'all. Down. You got long nails. Square root of 25 is 5. And it looks like we got all the information we need. Let's just plug it into our formula. So theta is equal to cosine inverse of, what do we need? Our v dot w. So that was the first one. We need our v dotted with w, and that's negative 16. So we pop that in up top. And since our magnitude, the dot product was negative, just letting you know, we're going to have a negative inside of a cosine inverse. And whenever you have a negative input into cosine inverse, that means we're in the second quadrant. I know I'm speaking quickly, but that means you have an angle larger than 90 degrees. Anytime the inverse, the input of the inverse cosine is negative, it means you have an angle that's bigger than 90 degrees. Because the magnitudes aren't going to be freaking negative, right? Now we got to put together these two suckers. 13 times 5. Over 65. So punch in a calculator. I didn't even look. What's it going to be? Second cosine inverse negative 16 divided by 65. Well, shoot, this looks to be about 104.3 degrees. And there's our solution for number 1. All right, so my lovely drawing was a little bit off. Need to be a little bit better. So let's tackle these. Let me do something real quick. Let's move it on over. I was going to use so much space. Cool. And let's go tackle number 2. Let's see one that's not going to turn out so clean, right? I gave you all the what we call primitive Pythagorean triples. So if we draw this up real quick, let's look at v. 2, negative 3. That's kind of, oh, jeez. Wow, come on, dude. 2, negative 3, maybe something like that. And then we got 7, 8 for another one. So that one's going to go kind of like this. Oh, we got another one. All right, so it's somewhere around 90. Maybe, probably over 90. Well, we'll find out. Let's see what's going to happen here. So let's go get our V dotted with W. And our V dotted with W is 2 times 7, so 2 times 7. And then plus, and then we got negative 3 times 8, negative 3 times 8. And what's that equal? It's 14 minus 24, which is equal to negative 10. Oh, since the dot product was negative, we know that that thing was larger than 90 degrees. Okay, let's keep going. Let's keep going. Now we need to also get our magnitude of vector V. And we're going to need to get the magnitude of our vector W. Now again, I said this isn't going to turn out quite as clean as the other ones. So let's look at vector V, which means we're going to take a 2 squared plus a negative 3 all squared. And what is this? That's 4 plus 9. We're going to get a root 13. Ooh, that's not very clean, but it's something. Okay, keep going. We get our magnitude of vector W, so we'll just go take these and, the 7 and the 8, we'll square them up, we'll add them up. So 7 squared plus 8 squared, that's 49 plus 64? 49 plus 64. Geez, you hear me with the calculator? I'm literally like, I want to redo this thing because I write the wrong number down. That's the square root of 113. Okay. Well, don't we just need to take it, plug it into our formula, and we can figure out where our angle is. So theta is going to equal cosine inverse of V dot W. That's up top. That's negative 10. And then times the two magnitudes put together. And now you got to get that thing into a calculator without making a mistake. Now, I want you to try and do it right now to make certain that you can do this and you don't make some silly error, because you're not going to know if you make an error, if you fat finger it and you don't know what any of the crap means. Let's make sure. And because you're never going to get, if there's a domain issue, do you know whose issue it is? Yours. It's never the problem. Don't write undefined. Don't give me that bullshit. It's there. They are vectors. There will always be an angle. So our theta here, I got approximately 105.1. And if you want to use radians, go right ahead. I'm just using degrees because it typically makes a little bit more sense to us in degrees rather than in radians. So when I give you, oh yeah, that was 3.6 frickin' radians, this means shit, but I know the degrees gives a little bit more thought. All right, let's go get our last one. Let's wrap this crap up. Oh, so we're going to take this and, all right, vector V. All right, let's go get our V dotted with W. Let's go figure out what that is. So we're like, all right. So we got to take our components, our these ones, right? Put those together. All right, so 6 times negative 6 first. 6 times negative 6, and we got to add it to, what do we got here? We got negative 4 and negative 9. 4 and negative 9, so that's negative 36. So that's 2 negatives, is that negative? No, that's positive. Okay, so you get negative 36 plus, that's equal to 0. Oh shit. Well, there's no reason to keep going. We're done. I know that both of these have at least some magnitude. Why would we continue to go at this point? Our formula is that theta is equal to cosine inverse of, well, some values that we know are there, and a 0 up top. So what's 0 divided by anything that's not 0? It's freaking 0. So this is telling us we have cosine inverse of 0. And of course you all remember exactly what this is. That's 90 degrees. So it turned out that if you have a dot product, if V dotted with W is equal to 0, that implies you have a 90 degree angle. And if you have a 90 degree angle, the dot product is going to equal 0 as well. So if we were to actually draw this up, 6 comma negative 4, maybe something like this, negative 6, negative 9, it would have looked a little something like this. And well, my shitty drawing, but it would form a right angle. Now let's go actually see the theorem here. Right down here we have a theorem, my bad. And it's a new term for us. The vectors, U and V, are orthogonal. It's another term for 90 degrees or perpendicular. Kind of think of it this way. Perpendicular. So, if you got a dot product that equals 0, you got two vectors that form a 90 degree, or what we call orthogonal, or you can think perpendicular. That is our game. So if you ever get that dot product 0, think about it. Stop. It's got meaning. I wonder what it would mean if dot product equals something else. I don't know. We're good to go. So I think that should end it. Enough with this. Enough work. I think you're ready to go and solve your worksheet. Later, y'all.